Okay, this problem number 8. I'm asked to find all the rational zeros for this function. You'll notice this is one I cannot factor out immediately because I have this -3 over here that does not have an x value that I can pull out. So I'm kind of stuck with this x cubed business here. All right, the first thing they want are what are the possible rational zeros? Because I'm going to use synthetic division, and I don't want to randomly, arbitrarily just start plugging in numbers to see if they work. So the way we do this, this is my p, this is my q, okay, my leading coefficient there. It's always p over q. And then I'm going to go ahead and list out the factors of these numbers. The factors of -3, it is prime. It's either a +1 and a -3 or a -1 and a +3. The way we write this out is ±1, ±3. Okay? The factors of 2 go on the bottom. And again, it's either both +1 and +2 or -1, -2. So ±1, ±2. And now I'm just going to make as many fractions as humanly possible. Okay? Like 1 over 1 is just 1. So up here, ±1 is one of my options. Okay, I don't know if it's a +1 over negative or vice versa. I'm going to continue with all of the possible rational zeros that have a numerator of 1, and the next one would be 1/2. So ±1/2. And then I'll lead with a 3 in the numerator. So that's 3 over 1, ±3. And last but not least, 3/2. And that's all my possible rational zeros. Now, I'm going to go ahead and use synthetic division. And I'm going to kind of cheat. Okay, we're going to use our calculator to help us out a little bit here because I'm going to go ahead and drop down my numbers here to break up this polynomial, -3. And I'm getting all of these numbers from my leading coefficients to these variables here, -8, and then my constant here at the end. Now, I don't want to arbitrarily just start plugging numbers in. Like, okay, does 1 work? And if it doesn't work, then I'd say, okay, does -1 work? And if it doesn't work, I'd probably skip the 1/2. Does 3 work? Okay, does -3 work? And then if that didn't work, I'd be like, does 1/2 work? And that'd be a pain. I could do synthetic division a long time. So we're going to let you cheat. We're going to let you use the calculator to find one of the zeros. You'll notice I typed it in here. Okay, and now I look at my table, and I actually have 2 options. I've got 3, 0, and -1, 0. And I'm going to use -1 just because it's a little bit easier. All right, now that we have this, I'm going to go ahead and scroll up here so I can see a little bit better. I'm going to put a plus here. My first number drops straight down. Okay, the way I get this next number is I multiply the bottom row by whatever is in the box. So right here, I'll draw an arrow up, and that will produce a -2. And I add down in vertical columns. I get a -5. And again, I multiply by what's in the box, and I get +5. And I add down in vertical columns, I get -3. And I multiply by what's in the box, I get +3. And this is what I want. I want what's called a remainder of 0 here. Okay, I'm going to go ahead and write out what I have so far. And right now, in factored form, I would have x plus 1. Okay, and I'm getting this +1 by what I found in the calculator, what's in this box up in this area here. And that we already know works because we typed it in our calculator. I'm going to turn this now into a trinomial. The bottom row of this synthetic division turns into a trinomial. 2x squared minus 5x minus 3. This is something I should be able to factor. So again, I've got x plus 1, and then I'll go ahead and break it up into 2 binomials here. The only leading terms that will produce x, or 2x squared, excuse me, are 2x and x, and these can be flip-flopped. Pen here, 2x and x. I notice my signs. The last terms are going to multiply to give me a -3, but since it's negative, I know my signs have to be different. And I'm going to go, let's see, Let's go plus and minus, and I might have to flip-flop those. And then numbers that multiply to 3. It's either 1 and 3 or 3 and 1. I'm going to go 1 and 3. And again, when I'm checking my FOIL, I don't waste my time multiplying these two. I know 2x times x is 2x squared. I don't waste my time multiplying these. I know positive 1 times negative 3 is negative 3. I do check my outers and my inners. Okay, that's 1x, that's negative 6x, and those do combine to make negative 5x. So I factored it correctly. Okay, now that I get to this point, this is my factored form. I can go ahead and write that out up here. So f of x equals, in any order really, x plus 1 times 2x plus 1 times x minus 3. All right, my zeros. Okay, we already know in this set of parentheses my zero is going to be negative 1, and we saw that it worked in the calculator. You'll notice over here in this set of parentheses, the only number that would go, create a 0 in that set of parentheses is positive 3. And that was also in the calculator too, so we already knew that one was going to work. And then last but not least, right here, if you get to a point where it's something a little bit weird where you just can't eyeball it, you have to make a little two-step equation that looks like this. When will 2x plus 1 equal 0? And it's a two-step equation. Subtract 1 from both sides, divide by 2, and my final answer is negative 1/2. So these are the answers I'm looking for. Can you write it out in factored form? And can you produce the correct zeros? And we're done.